Hey folks, so I am going to do a video walking you through Lab 8 with an actual example. I won't use any of the data sets that you'll probably be using. I'm going to use a different data set because I don't want to give you all the answers. But hopefully walking you through a similar assignment with a different data set and different types of questions will allow you to see how to resolve some of the issues that you've been encountering. So I have this data set here on hydropower. I've already downloaded it and I have it down here. So I'm going to go through the lab, through all of the tasks that you'll be doing. So I've already read the information about the data set. I'm going to be working again with this hydropower data set, which is not one of the 3 options that you have. So I've read about what it has. I have already downloaded. You can see it here in my downloads, hydropower CSV. Identify what the data is, how to read it, what does each column represent, are there any abbreviations or codes, what do they mean? Okay, so I've seen already what my column titles are, what type they are, and some example values. The other thing I want to do is look at what the actual file looks like itself. So this is what the file looks like itself. I see everything surrounded by quotes, which is similar to what you'll see in your data sets. And okay, this looks fine. How many entries are there out of curiosity? Okay, I have about 337 entries minus that top column, 336 entries. So that's how many I'll be expecting when I run my project. Okay, so look at the questions below. For this, we're going to come up, I'm going to come up with some additional questions that are similar to these so you can get an idea of how to do both. Review the code. I've done that extensively with both sections, so I'm not going to do that again. And then I'm going to go ahead and download this file. Implement read CSV, keeping only the data necessary to answer your datasets 2 questions. Okay, so now we need to come up with questions, right? So let's say, for me, for this example data set, I'll say that question 1 is, what percentage of hydropower projects, well, I can't spell, hydropower projects were built after, let's see, 1980. And that is information that we get from here. We get the project year. And then let's say that my question 2 is how many let's see, what other data do we have here? Okay, let's work with elevation. How many hydropower projects have an elevation of over 1,800 feet? Probably. This is probably feet. So feet. So these are similar to the questions that you have for your own specific data sets. So have to go back now to task 4 now that I actually have questions, right? So do you need a map or a set to answer each question? Which columns from the data set do you need to answer each question? So for this one, percentage of hydropower plants, hydropower projects, percentage means that I'm going to need at least 2 values, right? Because there's those, in this case, those that were built after 1980 and those that were built before 1980. I'll say on or after. So for this one, right, so because comparing values pre-1980 and post-1980, need a map. columns 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So column 11 has year. And then, well, if I store just the year, right? So as, oh, this was an accident, but perfect. If I store the year and there's 2 years, right? 2 projects that were built in the same year, my count is going to be off. So I have to think about what data value is going to be unique to each hydropower project. If I'm having trouble with that, I can go up to the examples that I have here and find a question that's similar to this, right? So let's see, we're comparing values. So maybe something like this. How many more CS majors than CE majors? So go down here. How many more CS majors than CE majors? Since you want to keep track of how many students are in 2 distinct majors, you use a map. Okay, so I was right. We do need a map. By storing the major as a key, so in this case they're using major, and the number of students with that major as a value, you can then answer the question by iterating through the map and printing each value pair. Okay, that makes sense. So let me actually put these in the same tab, so I can stop doing that. So column 11 has year, key equals pre-1980. Oop, that was, and post-1980, value equals number of projects from that time period. So that means, so if my key is going to be, in this case, a string, and the value is going to be the number of projects, that means that my key type is going to be string for my map, and my value type is going to be an integer. Okay, so question 2, how many hydropower projects have an elevation of over 1,800 feet? So go back to our data. Elevation is the first column. So column 1 has elevation. And then because I'm keeping track of how many, I can use a set. Use set to keep count. And this is the case where, you know, now if I just store the elevation itself, if 2 projects happen to have the same exact elevation, then I'm not going to be doing my count right. So what is something that each project has that's unique? Each project has its own specific name, right? And those are all going to be different. So even if they have the same elevation, they're going to have different names. So that's going to be 1, 2, 3, 4, column 4. Use column 4 to store names in set. So since I'm storing names, the type of my set is going to be string. And so I've successfully completed task 4, right, which is going to scroll back down, columns from the data set you need to answer each question. That means all these other columns I can totally ignore because I won't be using them. So now I go down to step 7, implement read CSV, keeping only the data necessary to answer your questions. Sets can be used to answer questions as to how many unique values does the value exist. Maps can be used to answer questions how many unique values of different types or how does one compare to another. I see these notes about strings, and so this data set is a good example of this because this actually happens in our data set. So when we're looking, for example, at the elevation itself is actually surrounded by strings, or these quote characters, which means that the entry, when it comes in, it's going to be a string, and that string is going to include those quote characters. So when I try to convert it to a number, it's not going to work, and I'll actually show you what that looks like. So I'm going to go ahead and implement my code to insert the appropriate data. And I know that I have an example in the Replit, so let me go to there. Cool, that's fine, don't load. There you go. Okay. So yes, you could copy paste this, but if you copy paste, you're not going to learn. So I recommend that you don't do that. Also, if you copy paste, you don't know what we've already given you. I already have my stream. I have my line. It looks like I need my entry. Ooh, excuse me. So std string entry. It looks like step 1 was already done for me. Or no, step 1 was done here. So let me actually put a comment here. Step 1, create instance of ifstream. And then step 2 is to open the file. So that's over here. Open file. It doesn't look like the error checking is done. So let's go ahead and do that. So if data.fail, std see error, can't open, and then let me give it the file name, and then do a new line. I forgot how to do new lines. There we go. And we return 1. Actually, this is a void, so you can't return a number, but you can just type return to exit out the function. Now we want to keep track of the row number we're at. We have our first while loop, which reads the file line by line. We create a new stream, streamline line. I should write down what these columns are. I have up here what I need, but it's good practice to have these out here. So let me copy these. It's going to give me a lot of stuff that I don't care about. So I'm just going to get rid of those things. We height, name, watercourse, county, latitude, longitude, state, org here. And so this is column. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this will allow me to check, do a quick visual check as I'm parsing my file. So now I keep track of the column inside this while loop, create a new while loop to actually break down the entry. So that's std getLine, streamline, entry, and I'm delimiting by a comma. And this line is just printing every single thing that I have, but I don't really care for that. Right? I don't need to do that right now. I need to keep track of column 1, 11, and 4. So something if 1, this will be for elevation. I'm going to do, oh, sorry, not 1, 4, which keeps track of the name. Having curly braces would probably help. And then column 11, which keeps track of, what was 11? Year. Okay, so by comparing value, okay, column 11 has years, key equals pre-1980, post-1980, value equals number of projects from that time period. Okay, so 11 is going to be used in my map, and I'm looking for projects that were built on or after 1980. So most likely what a lot of you were trying to do was you were trying to do a story. So you were doing something like entry, so int year equals entry. But just so that you could see what that looks like, I'm going to do a cout, just so that you can see why this doesn't work. Cout, or not that why it doesn't work, that it doesn't work, period. So I want to keep track of what row I'm at, just to see, you know, if there's any funny business that happens, I want to make sure that I know what row it is, so that if I need to go into my hydropower.csv, I know which row to look at and edit. And then I can say :11, and then print out the int, no, not the int, sorry, the year, and then do a new line. So let's start with that. And I just have this stuff hanging out in my downloads. So G++, standard equals C++ 11, and I just have lab08.cpp, lab8.0. Okay. Ooh. We've got an error. String stream. Did I not include my string stream? I did not include my string stream. So I need a hashtag include, and that is S stream. All right, let's try it again. Beautiful. I'm going to go ahead and execute lab8. Oh, I didn't even give it the file name. Silly me. Okay, hydropower.csv. Let's try that again. Nothing outputted. Oh, I'm never increasing my column, so column 1 never changes. That was silly. Okay, so I have to increment my column inside the innermost while loop, and I increment my row in the outermost while loop. Okay, take 3. Terminating with uncaught exception of invalid argument story, no conversion, abort trap 6. Well, shoot, why is that happening? Let's try to print this above. Instead of printing year this time, we'll print the whole entry to see what's going on and why it can't be converted. Run that again, lab8. Oh, so no, these are all announcements that I made on Piazza, and some of them I actually said in class. So this happens when your header row is there, so you can just get rid of that now that we know exactly what they all are. So I can just get rid of that, save it, try running this again, and you see that the error changed. So when you change the CSV file and just the CSV file, you don't need to recompile your code. As you can see, the error that I'm getting is different. Well, it's the same error but with a different value. And so to us, we see this, and to us it's very obvious that that is a number and that that number is 1965. However, for C++, because the number is surrounded by these quotes, the way story works is it looks at every character and determines to see if that character is a number. The very first character here is a quote, and so a quote symbol is not a number, and so the whole story function crashes. So that's why we can't use story when our data set has numbers that are enclosed in quotes. So if we remember from the Piazza symbol, the Piazza announcement, like, oh, I remember the professor talking about this. Lab8 and numbers. Okay. So we want to escape with the backslash character, the value, and then use that as a comparison. So we're gonna start slow here. So let's, I forgot what the year was. I wanted 1980. Okay. So if entry is greater than or equal to, so we're working with a string, and then we have to backslash, put in another quote. We'll look for 1980, do another backslash. So in this case, my text editor actually changes the color of an escape sequence so that you know that that's part of the string itself. So that quote symbol is going to be part of the string, and then the 1980, and then we have another quote, and that's all surrounded in quotes because that whole thing is a string. So I just want to do, in this case, just to confirm that this works, I'm going to say post 1980. Otherwise, I'm going to say pre-1980. And I'll compile and run this because I want to do, every time I do these changes, I want to do a visual check. I want to make sure that I'm not just making stuff up and that things are actually going to work. Probably doing some new line characters here would be helpful. Neat trick, you can do a backslash tab to indent something. Okay, so I'm going to run this to make sure that my check for years is working. And it looks like for the most part, 34 is pre, 7 is pre. Let's make sure that the post 1983 is indeed post 1980. So, okay, that looks fine, but it does also look like I'm getting some random values that are not years. And so this happens, like I feel like I remember reading about this. Data cleaning may be required if there's commas in the names, titles, or industries. Okay, so the nice thing about printing out the row value, the individual row value, is that I can go ahead and find which rows are culprits and remove those commas. So I refreshed the file and forgot to get rid of the header. So let me get rid of that again. So now all of these are going to be offset by 1. So row 6 is now row 5. We want to get rid of any commas that are inside the quotes. So we've got that. Row 6. Get rid of that. Row 9, which is not going to be 8. Get rid of that. And I'm just going to speed forward through me deleting all of these commas because it might take a little bit. Okay, I'm back. I think I've gotten all of them. So I'm going to double check. And again, when you only update the CSV file and not your code, you don't need to compile. You can just run this again. Okay, so looks like I missed one. In 305. It's another one in 241. Okay, I missed a couple. So I can go back and redo this. I only missed 3. 4. Okay, so I can go ahead and re-find the ones that I missed, or I can show you a trick that's going to change some things. So this I was doing on my text editor, which, that's what I used to go code. Some of you are using this, your CS50 IDE, or maybe you opened it up in Notepad or text editor or whatever. If you have Excel on your computer, or if you have a Mac and you have numbers, or if you upload this to Google Sheets, let me create a copy of this so I can show you what happens. lot of files here. So I have my hydropower, which is this one that I was messing with, and I have this copy. Let's say I open it on Excel or Numbers or Google Sheets. And I know that all of these commas are coming from this column over here, which had the name of the company. So there's no commas in states, there's no commas anywhere else. It's literally just this column. This is column 10. Column 10 has the project organization. I don't need that for anything. So you know what? I'm just going to get rid of it. I'm just going to make my life easier instead of going through hand by hand and getting rid of that. I'm just getting rid of each comma. I'm just going to goodbye. And I will save this. This only works if you're not using the column. If your commas are unfortunately in names, which you might be using, then that's a different story. But in our case, we got really lucky we weren't using that column name, and so we can just get rid of it. However, after you have opened a CSV file in Excel or Numbers or Google Sheets, when it resaves it, look at the difference. There's no quotes anymore. So it's going to change things a little bit. So now, let's say we leave everything as is, except because we got rid of column 10, we moved, now we're going, everything after 10 will move one back. So now this is going to be column 10. So now that we've updated our code, oh, and I have a different file. I'm working with hydropower copy, just to show you. So I'll compile my code again, run it. You'll see that now my years are off. So now it says that 1951 is after 1980, which is not correct. And the reason that happens is that after you open in Excel or Numbers, this is why you always have to double check your file with a text editor. Since the quotes get removed, we no longer need these quotes here. So because we opened it in a different file, in a different application, in this case, which was Excel, which by the way, you all, as URI students, have free access to the whole Word suite, so you can download it and then just log in with single sign-on and you get Excel, Microsoft Word, and PowerPoint for free, so you should definitely download it because they're very beneficial. In any case, because we opened it with Excel and then save it, even though it's still a CSV, all of the quotes were removed. So the stuff that we were doing here is unnecessary. And now we can just actually leave this as 1980 without the escaped sequences. So let's try that again. So 1960, pre-1980, which is correct. Let's find a post. 1985 is after 1980. That is correct. We still have a comma somewhere that shouldn't be there. So let's go down here to 305. Where are you? Why are you doing this to me? Okay, there you go. Goodbye. Let's see, are there any other shenanigans going on? Oh, we got another one in 241. So sometimes you'll have one column that has a lot of commas, and you get rid of it, and then apparently there's another column that still has commas. So that's slightly depressing, but it's okay. These are, the joys of working with real data sets. Data cleaning is very much a very real and many times painful part of working with real data sets. Ooh, look at that. Nope. Ooh, I accidentally almost deleted the wrong one. I want to get rid of that comma. Ooh. There we go. That's the comma I don't want. Okay, any more shenanigans? $57. Negative numbers, probably not a year. Oh man, look at this. Got 2 commas here. Oof. Big oof. And hopefully last but most definitely not least, got a comma somewhere here. Okay. So we updated our CSV, not our code, so we can run this again. And I think we got them all. Beautiful, beautiful. Okay, love to see it. A trick that I showed another student earlier was, so CS50 IDE, you can't do infinite scroll like you can on your built-in terminal. So if you want to be able to see all of the output, but CS50 IDE is not letting you because it only lets you scroll up to a certain point, a neat little trick you can do is you can redirect or pipe your program's output to a file. And you do that by, instead of just running the program by itself, you do the little angle bracket and you give it a file name. So this would be your out.txt. And you'll see that nothing printed on the console, and that's all because it's on this file. So I created this file, your out.txt, and I have all of that output saved in a nice little file, so you can access all of it. This will be super useful. You know, like I said, I only have 300 and something entries or rows, but if you have a couple thousand or several thousand, looking at it in this form is going to definitely be easier. Okay, so we've got one part done. We haven't even gotten to maps or sets. Literally, this is just the data cleaning part. So let's make sure that we can do this correctly in this case as well. So elevation, we were looking for over 1,800 feet. So I'm just going to do the same thing here. And column 1, entry, 1,800. They're going to be greater than 1,800. And the question asks for greater than, so I can get rid of that equal than. To be less than or equal to 1,800. So now that we've cleaned the data for this, I'm just going to comment that out. I know that it's working and that's fine. And then just good check. Make sure that nothing funny is happening with our name. We don't even have to check for anything. I just want to make sure that the name is being parsed correctly. Okay, so let's run this again. Where are you? Compile, run, and we're going to save this as new out.txt. Let's look at our file. 1520 less than or equal to 1,800. That's correct. The name looks, it says damn, so we know that it looks good. Elevation here is definitely greater than 1,800. And just from a quick skim, it doesn't look like there's anything funky happening, right? So all of our names have dam because they're all dams, and these second ones are all numbers. Okay. And this is again just to make sure that there's no funny business going on with your data set. Number 1.5 dam, interesting name. Okay. You see, I'm scrolling through this pretty quickly just to see if there's anything egregious that sticks out. Okay. Cool. All of this looks fine. So now that our data is clean and we know that we are reading it incorrectly because we're getting all of the information that we want, now we can go ahead and answer our questions, or actually add data to our maps. So I'm going to get rid of, or at least comment this out. I don't want any more couts. Okay, so we said, let's see, let's go back to our notes. I already forgot where we were. So for column 11, we said we are using a map. That's what we're using our map, my map for. I already actually have my if statement here. So now what I can do is if I say my map and I'm keeping track of, so if it's greater than or equal to 1980, that'll be post. And doing a plus plus because, so the nice thing about this is because we already said that map contains integers, they all start at 0. So when I get post, even if post isn't a key in my map that exists yet, it essentially creates it, assigns it 0, and then increments it to 1. That's a really nice feature about C++ that you won't see in other languages. In most other languages, you would have to check if the map contains the key. If it doesn't contain the key, then you would have to create the key. And if it does contain the key, then you would get and increment the key. And so for those of you coming in from Java, the process, for once, is longer in Java and more painful in Java than it is in C++. So that is, shout out to C++ for getting at least one thing right. So greater than or equal to 1980 is going to be post. I'm going to use pre as the key, and then plus plus to keep track of that. So gonna call that a day. Actually, you know what? Before I call that a day, let's check to make sure that things are happening correctly. So let's make sure that we got a right amount added. So now if I get pre, let's do std cout. Just to see, make sure that we got things added to both. And honestly, that we got all of our entries, right? So we said that there were, I'm working with hydropower copy. There are 336 entries. So whatever outputs, whatever two numbers output here should add up to 336. So let me compile. Nope, that's not what I wanted to do. I just want you to print out to the console. Why am I still printing stuff? Oh, there we go. $325 plus 311. Nope, sorry. 325 plus 11 is 336. And we indeed have 336 entries. Beautiful. Cool. Things are working. So we will fully answer the question later. We just wanted to confirm that things were being added correctly. So we can get rid of this. For this one, we were checking to see column 1 has elevation, use column 4 to store names and set. How many hydropower has an elevation of over 1800? Okay, so we said we're going to store the name because that's the one item that's unique to both. So we want over 1800 feet. So we only want to store the data if it goes over. So in this case, we can just say my set. Oh, actually, wait, we don't have access to the name here. So in this case, and this will be different for some of you. So some of you will have the unique identifier as one of the first columns. Some of you will have it after. So if you have it as one of the first columns, you can keep track of it and then use it to insert it into your set. In my case, because column 1 gives me the elevation, which is what I'm comparing, and column 4 gives me the name, I'm probably going to want to have a Boolean that says over elevation. It'll always start at false. And I want to do that for every row. At every row, I want to restart it to false, just like I restart my column to false. Just like I restart my column to 1, excuse me. So if it's over 1800, which we care about, then I'm going to make over elevation equal to true. And I can leave this here as a false just to double check. But because I'm setting it here to false, doesn't matter. So now, when we finally get to the name, because you're reading these entries one at a time, when we finally get to the name, I want to check if over elevation, which is already a Boolean, so I don't need to say equals true, because it is a Boolean, so it's either going to be true or false. But if you're more comfortable having the true there, that's fine. Then I'm going to do my set.insert entry. And in this case, remember that the entry is the name. So let's go out here and print out how many elements are in our set. And we get 286. So there were 286 values that are over 1800, whose elevation is over 1800. So, okay, we have read our files and we have confirmed that things are being added correctly. So now we can properly answer our questions. And I just want to reiterate, so I created this Boolean to keep track of whether we were going to add the element to the set or not, so that when we eventually got to the name, which shows up later in the column, right? It shows up in the fourth column instead of the first. We could keep track of that. If your unique identifier is in the column that's earlier, you would actually want to store the name, always store the name, and then when you get to the check, so let's say that these were reversed, where my name was in 1 and my elevation was in 4, I would store the name as soon as column was 1, and then if the entry for the height or the elevation was 1800 greater, then I would insert the name that I had previously saved. So that's how you keep track of information that appears before that appears in a previous column that you're going to need later on. So let me copy over both our questions. And you know what? I'm actually going to see out them. So I'm going to do std see out. Get rid of this. Will be std and line. And so to calculate, let me make this big again. To calculate this, what percentage of hydropower projects were built? So I gave everyone a hint for how to calculate that in their questions, right? So I say calculate how many blah, blah, blah versus not, and then divide it by the total. So in our case, we're going to say, we're working with a percentage here, so we can use a float or a double. Float average equals, so on or after, we saved in the map as post, and we need to divide that by the total, which will be post plus pre. You want to make sure that things are spelled correctly and are consistent all the way across, otherwise you're going to get some weird values. And then to get a proper percentage, we would multiply that by 100, otherwise we're going to get a decimal. So then I can do std see out, I can get fancy and do my tabbing, and say average percent were built on or after 1980. And just because I really don't like typing that out, I'm just going to say percent of dams. All right, and then question 2, how many hydropower projects have an elevation of over 1,800 feet? So in this case, we're actually just getting the size of the set because the set was storing the unique names of each dam that were over 1,800. So I'll just do std see out, and I really enjoy tabbing things. I think it looks so pretty on the terminal. And then we would give my set.size. Tab dams have an elevation of over 1,800 feet. Okay, so let's run this and see what it looks like. What percentage of hydropower projects were built on or after 1980? 0% of dams were built on or after 1980. That seems wrong. Something has gone awry. Okay, we'll have to look into this. How many hydropowers have an elevation of over 1,800 feet? 286 dams. Okay, what is going on here? Should this actually be 0%? So if we remember last time, we just did a C out on the number of dams, because maybe it's a small enough percentage where it's calculating it to 0, but that seems weird to me. Post, and then let me do pre, and then we can do that calculation manually. Okay, so we have 336 total, and the number of in 1980 or after were after, so that would be 11 divided by 336, which it's 0%, but it should be giving me a decimal, a proper decimal, and it's not. So what happens if I don't multiply this by 100? Does it give me the actual 0.03? Okay, so something weird is happening. What if I make this a double? Am I doing math wrong? And total equals my math pre plus post. If I do an STDC out, if I save this as a double and I say 11, let me just do this to confirm what is happening. 11 divided by that, and then I do, oh, I should probably name that double. Calc, STDC out. Nope, not called double, it's called calc. Let me print out the total to make sure it's 336. Okay, so it is calculation. It's rounding this down to 0. Oh, I set this post. It's pre. I was confused as to why this 22 was coming up, because I should see 11,325, allegedly a decimal, and then 336. Oop, I just compiled again. Okay, 336 is right. These two numbers are right. I don't understand why my double is getting truncated. I don't want it to be truncated. So, time for let interweb. C++ print decimal places. It's like a set with or something. Oh, do I need the word F in there? Or the letter F? That seems wrong. Yeah, see, no, it doesn't like that. Set position, okay. Let's try set precision. Let's get rid of this ugly F. And set the precision to, say, 5 decimal places. Let's be generous. Probably need this guy, which is, it stands for I/O manipulation. That's how we can manipulate what is being outputted. And that did nothing for us. If I make everything a float, float num1 equals 11f. Oh. And then float num2 equals 336f. And then I say num1 divided by num2. Does it like that? It really doesn't like the letter F. 0.0? Does that make you feel better? It does. Interesting. Okay, now we're getting decimals that we want. Oof. Okay, so doing all of this, realizing, you know, you're getting 0%, what is happening? When these are floats, it works fine. What if I go back to 11.0f divided by 336.0f? Will it still print correctly? Interesting. All right, so it doesn't like integers. Let's try making this guy a float and see if we can get some proper position. There we go. So instead of using an integer, I'm using a float so that I can divide the float properly and give us an actual position instead of just rounding down to 0. So now we can try multiplying this again by 100 times 100. And let me get rid of all this extra stuff. 5, maybe 5 is too aggressive. Now let's leave it at 5. Who cares? There we go. So set position tells you how many decimal places to go. So if you wanted to round down and just leave it at 2 or 3, that's also totally fine. Whew. Did I not save that? Did I not compile that? Now it's left the position at 5. Okay. So 3.27% of dams were built on or after 1980, 286 dams for renovation of 1800. Alrighty folks, well, this video was definitely much longer than I anticipated it being, but hopefully going through a full example and seeing how to resolve some of these errors, seeing how to look some of these things up, right? Like I kept getting 0, and I knew that with the math that it shouldn't be just 0%. So hopefully that helps clarify some questions or conundrums that y'all were coming into. Alrighty, well, happy coding!